Hello everyone, this is Mr. McMillan and I'm here with an instructional video on the first part of the Pythagorean theorem. And we're going to be looking at a well-known theorem that is specific to triangles. Okay, so Pythagoras discovered this, well, along with him and his students over 2,000 years ago. And it helped explain the relationship between the legs of a right triangle and the hypotenuse of a right triangle. So before we start talking about this theorem in more detail, let's remind ourselves about the properties of right triangles and how we would label them to use the theorem correctly. So the first property, right triangles have exactly one right angle, which means that their measure equals 90 degrees, okay? So it has exactly one right angle. Well, let's look at this diagram. We're going to be marking this as we go along with the properties. Where is your right angle in this diagram? Your right angle in this diagram is here in this bottom left corner, right? It forms the corner, it forms a box, so to speak. And in order to mark this 90-degree right angle, we use the little corner mark, little box in the corner, and I'm going to put that this is 90 degrees. Okay. Number two, the longest side, which is the side opposite from the right angle, is called the blank. Now, if you remember from the last few lessons we did in the previous semester, we talked about right triangles, and we said that they had two different sets of sides. One was the hypotenuse and one were the legs. So the longest side is opposite the right angle and it's called the hypotenuse. So the longest side is the hypotenuse. Now remember, if you have sides that are opposite from angles, the side opposite from the angle that you're talking about is one that does not touch that angle whatsoever. So in this diagram, is it the left, bottom, or top that deals with the opposite side from the right angle? Well, if you look at your right angle, these two sides touch it, but this one doesn't. So this one is opposite of the right angle, which is your hypotenuse. Okay. Number three, the sides adjacent to the right angle are called legs. And specifically, there are two legs. The other two sides are called the legs. So our left side here and the bottom side. If you notice here, it says adjacent. That means next to or touching. So the sides that are next to or touching the right angle are called the legs. And as you can see here, this left side touches the right angle as well as the bottom side. So those are our legs. And number four, when labeling a right triangle, the legs are labeled with the letters A and B, while the hypotenuse is labeled with a C. So our hypotenuse here is going to be labeled with a C. Our leg, now it does not matter which one you use A and B for on your legs, but the way I tend to do it is the shortest leg gets the letter A and the longest leg gets the letter B. So I'm going to write that summary here. A is the short leg and B is the long leg. Okay. So as some of you guys might be asking, well, what's the purpose of the Pythagorean theorem? Well, the Pythagorean theorem has a lot of applications in science and everything else. So the Pythagorean theorem has a lot of applications in science, art, engineering, and architecture. For example, it's used a lot when cutting trees to make sure that they won't fall on houses and things like that. It's also used for staircases and other similar structures that require you to, build upon each one with a slope, because a staircase has, when they join here, they have a right angle, and your slope, right, is your steepness for those stairs. So you need to know how long to make each of the legs to make sure that these steps work correctly as you design them. So here's how Pythagoras originally stated his theorem. When a triangle has a right angle and squares are made on each of the three sides, then the biggest square has the exact same area as the other two squares put together. So our biggest square here, our biggest square is always going to be on the hypotenuse side. This is because it's the longest side. So the longest side, if you square it up, is going to make the biggest square. And then your legs are going to be your other two squares. So let's look at this graph and diagram to see and visualize what Pythagoras theorized. So if we look here, we have three squares indeed. We have the biggest one here and our two smaller ones. And you can see where the sides, or where the vertices meet. If we draw the sides there, we will see that we have a right triangle with A, B, and C side lengths. Our A is 3, and our B is 4, our C is 5. Okay, so let's look at this. It says the biggest square has the exact same area as the other two squares put together. Well, to find the area of a square, we take a side that we have and we square it. So we always take a side and then square it. Okay, so if we look here on this square, we have a side length of 3, and this is on a coordinate plane. It goes up 1, 2, 3 spaces. So the area of our small square here, 3 squared, is 9. Our area of our square here, 4 by 4, is 16. And here we have a 5 by 5 square, and that is 25. Okay. Now you can see here that this is written out using, cubing it and making it into separate boxes that are each the same area. So this is a 1 by 1 square, 1 by 1, so on and so forth. And you can see here that this has 9 squares total. This has 16 squares total, and this has 25, just like what we got here. Now, what Pythagoras said was that the biggest square, which in this case is 25, has the exact same area as the other two squares put together. Well, is that true? Does 9 and 16 add together to give you 25? And the answer is yes. Now, the way he wrote this out in a general format is using the letters A, B, and C, the legs and the hypotenuse. So your legs, your first leg here is A, and so you would have A times A because it's the area. And A times A gives you A squared. And then you have plus, then your next one would be B times B, which is B squared, equals, and then here you'd have C times C, which is C squared. So your Pythagorean theorem, and you guys have seen this before, you may just not remember it, is A squared plus B squared equals C squared. Okay? So let's formalize that statement on the next page. So in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. In other words, you take the square of one of the legs, added with the square of another of the legs, and you get the hypotenuse squared. So leg squared plus leg squared equals hypotenuse squared. So if the measure of angle C is 90 degrees, in other words, ABC is a right triangle, then we know that A squared plus B squared equals C squared. Okay. So we're going to do some example problems. We're going to do 1, 2, and 6 on this page, and then we'll do some more on the other side. Okay. So for 1 through 6, it says state if the three side lengths form a right triangle. So state if the three side lengths form a right triangle. So let's look at number 1. Again, we're going to do numbers 1, 2, and 6 together. Okay, so make sure you pay attention. So number 1, we have side lengths 10, 12, and 13. Now, since we have three side lengths here, we need to figure out what A is, B is, and C is. Always start out finding what your C value would be. And remember that C is the longest side. So in this case, which one would be C? 10, 12, or 13? Well, 13 is the longest side, so that's going to be our C value. Okay, now we want to label A and B. Now again, it doesn't matter, but I prefer to have A be the short leg and B be the long leg. So A would be the shorter of the two, 10 and 12. So A would be 10 and B would be 12. Now in order for these to be a right triangle, they have to satisfy this equation. So in other words, A squared plus B squared has to equal C squared. So let's plug this in. We've got A is 10, so we have 10 squared plus, then we have B squared, which is 12, so 12 squared equals, and then we have 13 as C, so we have 13 squared. Now, here's the point where you need to look at Desmos if you're having trouble figuring out what these are squared. So open Desmos and type in what you need. So the first thing is 10 squared, which is 100. And then you have 12 squared, which is 144, and 13 squared, which is 169. So going back and writing those in, you have 100 plus 144 equals 169. If we take 100 and add 144, we get 244. 244 does not equal 169, so this is not a right triangle. All right, number 2. Again, we want to find what our longest side is first, then figure out what our legs are. So the longest side here, we have 12, 15, and 9. Well, the largest number here is 15. So that's going to be our C value. A will be our shortest leg, which would be 9. And B would be 12. For this to be a right triangle, again, it has to satisfy A squared plus B squared equals C squared. And we're going to plug those values in. A is 9. B is 12, so we have 12 squared here. And we're going to see if that equals C squared, which is 15 squared. 9 squared, again, if you need to use Desmos, I'll go ahead and tell you what it is, but use Desmos if you don't know. You have 9 squared is 81. 12 squared is 144. And 15 squared is 225. So you're trying to see if 81 plus 144 does indeed equal 225. 81 plus 144 is 225. Last time I checked, 225 is equal to 225. So this is a right triangle. So you would put yes. All right, and then the last example we're going to cover together on this page is number 6. And if you look at number 6, you should notice something a little bit different from numbers 1 and 2. And this is the way that some of these problems are going to get you if you're not paying close enough attention. So if you look here, you have 1 mile, 2 root 3 miles, and 4 miles, okay? Now the first thing is we want to figure out what our longest side is, but this radical makes it a little bit difficult. So what we're going to see here is what 2 root 3 is and see whether the 4, 1, or 2 root 3, well the 1 wouldn't be, but whether the 4 or the 2 root 3 would be larger. So if we go to our Desmos here and type it in exactly like this, 2, and then your square root, and then 3, and that gives you 3.46. So when we want to label this, we would say that our largest side is 4. So we're going to label that as C. Our next largest, or sorry, our smallest is 1. So we're going to label that with A. And we're going to label 2 root 3 with B. Just like the other two that we did, this has to satisfy a squared plus b squared equals c squared. So we have a squared, well a is 1, so we have 1 squared plus. Now here's where it's important. You know, you remember in algebra when your teacher would always get on to you about, did you remember your parentheses, right? Well, you know, this is going to be important to have your parentheses here just to make it as clean as possible. So since this is a radical, I'm going to put a parentheses and put 2 root 3 in parentheses and then a squared outside. I'll show you how to put that into Desmos just to make sure we're clear. Then that equals c squared, which is 4 squared. 1 squared is 1. We'll get to that one in a second, and that's equal 4 squared, which is 16. All right, so we're going to put this in Desmos. So what you need to do, put your parentheses, 2 square root of 3, close your parentheses, and then since it has to be squared, you're going to put your squared there, and that's going to give you 12. You need to make sure you put your parentheses, because if you don't, let me just show you what happens if you don't put the parentheses. You just put a squared outside that root 3. It's going to give you 6 instead of the correct thing, which would be 12. Okay. So this is 12. 1 plus 12 is 13. And last I checked, 13 does not equal 16. So this is a no, just like number 1. Okay. So part of what I assigned was 3, 4, 5, 7 through 12. Do those. They're practice problems. I'm going to have another video posted with the answers to these as well as the other example problems that I assigned for students to do for homework as well. And we're going to look at a few of those examples right now. Number 13, 14, and 19. So for 13 through 18, what it wants us to do is find the missing side of each right triangle, where side C is the hypotenuse and sides A and B are legs. So we have to see what we're trying to find, if we're trying to find A, B, or C. So let's look here at number 13. In number 13, we have A and B. Well, since we have A and B, that means we're trying to find C. Okay. Now, since these are right triangles, to find our missing side, we're going to have to use the Pythagorean theorem. So we have to use a squared plus b squared equals c squared. A says it's equal to 9, so 9 squared plus, then b is 12, 12 squared equals, and then c squared, because we don't know what c is. 9 squared is 81, 12 squared is 144, equals c squared. The c is already by itself, so we're just combining like terms on the left side. 81 plus 144 is 225, which is equal to c squared. Now, 225 equals c squared. Now, what you have to do here is you have to get rid of that squared somehow. Well, just like when you're solving an equation, if you had x plus 4 equals 5, you would subtract the 4 from both sides because you would have to do the opposite. Well, if you have c squared, you have to do the exact same thing. But the question is, what is the opposite operation of squaring something? Well, the opposite of squaring something is to square root it. So what we need to do here is square root both sides in order to get rid of that square. Because remember, what you do to one side, you have to do the other. So we're going to square root c squared, and we're going to square root 225. Well, the square root of c squared, the squared cancels out, and the square root does. C equals, and then if you go into Desmos and type in the square root of 225, you get 15. So that means that C is equal to 15, and technically it's 15 miles. And that's your answer. Number 14, you have B equals 7 inches and C equals 13 inches. So unlike the first one where we had A and B, this time we have a leg and we have a hypotenuse. But we're still going to do it the exact same way since this is a right triangle. So we're going to still use the Pythagorean theorem, a squared plus b squared equals c squared. We don't know what a squared or a is, so we just drop it down, a squared. B is 7, so plus 7 squared. And C is 13, so equals 13 squared. Okay, we can't do anything with the a squared, so we just drop it down. 7 squared is 49, and 13 squared is 169. Well, we need to get the a by itself, and this plus 49 is not doing us any favors, so we need to subtract 49 from both sides to get rid of it. So you get a squared equals 120. Just like before, we have a squared here, so we need to square root a squared. What you do to one side, you do to the other. And you get that a is equal to root 120, or in decimal rounded to the nearest hundredth is 10.95. Okay. Now on a quiz or a test, you'll see this in simplest radical form. All you need to do is see which decimal would match with what you have. All right, and the last example we're going to do in this video together is number 19. And number 19, it's the exact same thing, just this time we have a picture instead of text. So number 19, we want to find the missing side of each triangle. Well, let's look here. What sides do we have? Do we have A, B, or C? Well, if you look here, we see that this side is labeled 2 root 3, and this side is labeled root 11. And those two sides both touch the right angle. So these would be your A and B values. So A is root 11, B is 2 root 3. And X would be our hypotenuse value of C. Same thing, we know it's a right triangle, so we know it has to satisfy a squared plus b squared equals c squared. A is root 11. Well, since we have a radical, we're going to put that in parentheses. Then here we have 2 root 3 squared equals, and then c is x, so equals x squared. If you type square root of 11 into Desmos or into your calculator, you can also just say that, you know they'll cancel out, but if you do type the square root of 11 in, and then you square it, you get 11 back. So we know that the square root of 11 squared is 11. We already figured out that 2 root 3 squared is 12. And we know that we have x squared. 11 plus 12 is 23 equals x squared. We want to solve for x. We square root both sides. And then we get that x equals root 23. And if we plug that in to Desmos to figure out our decimal, we see that this is approximately 4.79 or 4.8. Okay. All right. So that does that for this video. In the other video, you can see some example problems worked out, numbers 3 through 5 and 7 through 12 on this page. You can also see 15 through 18 and 20 through 24, which is what I assigned in class for people to do for homework that we'll check over in class. Okay. I hope this video has helped, guys. If you do have questions about any of this material, please make sure that you ask questions. Join the Zoom and ask questions. Email me. The Zooms, are the best way to learn because I'm live and I can help you out in real time rather than delay or whatever else. So don't be shy to ask for help, because if you don't, and I don't know where you're struggling, it's going to be difficult to get you on the right track. Okay. In tomorrow's lesson, we're going to be covering the Pythagorean theorem's converse. Okay. That will be a video and doing some example problems on those, and assigning some IXL for you to complete for a graded assignment. Okay, so that's it for me, guys. If I don't see you tomorrow, January 8th in class because of the snow, then, I hope to see you on the Zoom on the 8th. Thanks, guys, and have a great evening.